study about the first control system component, potentiometers. So what is a potentiometer? A potentiometer is an electromechanical transducer which converts the mechanical energy into the electrical energy. This mechanical energy is displacement, and this displacement can be either linear displacement or rotational displacement. So this displacement can be either linear or rotational. Okay, so this potentiometer, it converts the mechanical energy into electrical energy, and this electrical energy is voltage. So basically what a potentiometer is doing, it is converting the mechanical energy into the electrical energy. The mechanical energy is in the form of displacement. Displacement can be either linear or rotational, and the electrical energy or the output of the potentiometer is voltage. So it is converting a physical quantity into an electrical quantity. That is why it is known as a electromechanical transducer, because it is dealing with electrical and mechanical signals, and also it is converting a physical quantity into an electrical quantity. So it is known as an electromechanical transducer. So potentiometer, it is also called as the error detecting device. Because it is used as an error detector in the control systems. Error detector means it finds out the difference between the output signal and the input signal. So the potentiometers, they are used, they are very commonly used in the control systems because they are cheap and they are very relatively easy to use. Okay, so they are inexpensive and easy to apply and use. So this is about the potentiometer. Now we will study the types of potentiometers. As we have studied that the potentiometer, it converts the mechanical energy into the electrical energy, and the mechanical energy is in the form of a displacement, and that displacement can be either linear or rotational. So on the basis of that mechanical energy, that is whether the displacement is linear or rotational, the potentiometers, they are of two types. First is the translational, or we can say linear potentiometers, and second is the rotational potentiometers. The translational potentiometers, they convert the linear displacement into a voltage, and rotational potentiometers, they convert a rotational displacement into the voltage. Now, if we see the equivalent circuit of a potentiometer or a generalized circuit of a potentiometer, it will be like these are the fixed terminals of the potentiometer, and this is the variable terminal of the potentiometer. So it is a generalized, or we can say equivalent circuit of a potentiometer. This fixed terminals, here we will apply an input voltage, and at this variable terminal it will move on this resistance, and this is called the wiper. So this wiper moves on a resistance, due to which we will get an output voltage. So this input, that is the displacement, it is converted into the output voltage. The displacement is the input due to this wiper, movement of this wiper. So basically the potentiometer is converting the displacement into the output voltage. Now if we let us start with the translational or linear potentiometers. In translational potentiometers, when voltage is applied across the fixed terminals of the potentiometer, the output voltage, which is measured across this variable terminal, it is proportional to the input linear displacement. Okay. So when voltage is applied across the fixed terminals of the potentiometer, the output voltage, which is measured across the variable terminals, this output voltage, which is measured across the variable terminals, it will be proportional to the input displacement. Okay. So what the translational potentiometers they are doing, they are converting the input displacement into the voltage. Okay, output voltage. Now if we draw the circuit for the translational potentiometers, it will be like these are the fixed terminals and it is the variable terminal. Across the fixed terminals, we are applying the input voltage E, I, N. Okay. This is the total length of the wiper, that is YT, and the movement of this wiper, it is YI, that is the input displacement, and the output we will get is the voltage E out. Okay, so it is the equivalent circuit diagram of a translational potentiometer. Now, under ideal conditions, the ratio of this output voltage and the input voltage, it will be equal to the displacement ratios. Okay. So, under ideal conditions, so under ideal conditions, the ratio between the output voltage and the input voltage, output voltage is E out and input voltage is EIN. So it will be given by YI by YT. Okay. Now what is YI and YT? YI, it is the displacement from zero position. That means this is the wiper, and first this wiper is kept at the zero position. Now when the input voltage is applied, this wiper will be moved from the zero position. So this displacement from zero position is Yi. Okay. Now Yt, it is the total length of this translational potentiometer. So in the translational potentiometer, this ratio E out by E in, it is equal to Yi by Yt. So we can, from this ratio, we can find out the value of the output voltage, because input voltage is given to us. We know the displacement of the wiper from the zero position and also the total length of the translational potentiometer. So these three variables are known to us. So we can find out the value of the fourth variable. Now similarly, the rotational potentiometer, let us first see its circuit diagram. This is the circuit diagram for the rotational potentiometer. So in this potentiometer also, the ratio between the output voltage and the input voltage, it is equal to theta I by theta t. Okay, where theta I, it is the input angular displacement of the wiper, and theta t, it is the total length of the rotational potentiometer. Okay, so here also, under ideal conditions, okay, so this is the ratio between the output voltage and the input voltage, and it is equal to theta I by theta t. Theta I, it is the input angular displacement, and theta t, it is the total length of the wiper. Okay, so we have studied the two types of the potentiometers, translational and rotational potentiometer. Now, as we have said, and we have studied that the potentiometer is also called the error detecting device, and it is used as an error detector in the control systems. So what is the arrangement for that and how we can use the potentiometer as an error detector? Let us study it. So error detector, it means that it is finding out the errors. Okay. So error detector, what it does, it compares two signals. So potentiometers can be used as an error detector to compare the positions of two remotely located shafts. That is, there are two shafts which are located at a far distance from each other, and if we find out the difference or the positions of the two shafts, then we can use potentiometer for it. So let's see what will be the arrangement or what will be the circuit for that. So this is the circuit diagram when we want to use the potentiometer as an error detector. Now this type of arrangement, it is known as double-ended arrangement. Because we have connected here two shafts. First shaft is having the displacement as theta 1 and second shaft is having the displacement as theta 2. So this displacement means that this is the position of the first wiper and this is the position of the second wiper. So this potentiometer arrangement or this arrangement is going to compare the position of these two wipers, or we can say these two shafts. Okay, that is why it is known as double-ended arrangement. Okay, so in this arrangement, two potentiometers, they are connected with this input voltage. This input voltage is common in between them. It is applying voltage to both the potentiometers, and output is obtained across its terminals, and the common end of these potentiometers, it is earth. Okay, so this is the double-ended arrangement. So in this double-ended arrangement, this output voltage E naught, it is given by E naught is equals to Kp multiplied with the difference of the two positions. So this difference will give us the comparison, or we are through this difference we are comparing the value of the or the position of the two potentiometers. Now this constant Kp, it is given by the ratio of the input voltage and the theta t. So EI, it is the input of excitation voltage divided by theta t, it is the total angle of rotation. So the E naught, that is the output voltage, if we put the value of Kp here, it will be EI by theta t, theta 1 minus theta 2. Okay. Now if we draw the block diagram for this potentiometer used as an error detector arrangement, or for this double-ended arrangement, it will be like, here we are having E naught equals to Kp theta 1 minus theta 2. So first, because it is the potentiometer as an error detector, so we will draw an error detector here, that is a comparator, which will compare these two positions. So first input will be theta 1 and second input will be theta 2. Now the sign of these two positions, it will be opposite, that it is, if it is plus minus, this input signal will be minus plus. Okay, because we are finding out the difference between these two displacements. Now this input will be given to, this difference is multiplied with Kp, so we have a block which is having the transfer function as Kp, and the output is E naught. Okay, so this is the block diagram of the double-ended arrangement. Now as this Kp, it is equals to Ei and theta t, so this applied voltage or this input voltage, it is normally DC voltage. There's normally a DC voltage, and the polarity of the output voltage, that whether the output voltage it is plus minus or minus plus, so whatever the polarity of the output voltage, it will describe the relative position of the shafts, that in what connections or in what positions these shafts are located. So whatever be the polarity of the output voltage, it will describe us the relative positions of the shaft. And if it is in case of AC, in case of AC voltage, the phase difference will find the relative positions. So we are saying that this input voltage, it is normally we provide DC voltage as an input. So in the case of DC input voltage, the polarity of the output voltage will describe the relative position, and if it is an AC voltage, then the phase difference between the output voltage and the input voltage, it will find out the relative positions of the shaft. So this is how the potentiometer can be used as an error detector. Now comes the resolution of the potentiometer. Resolution is defined as So resolution of a potentiometer is the ratio of change in the output voltage in one step to the supply voltage. So if we write the formula for it, it will be, the resolution will be in percentage. So percentage resolution is the change in the output voltage and the ratio of the change in the output voltage in one step. So one step, it is ES, and as it is in percentage, so we will have multiplied with it 100. So it will be equal to, percentage resolution will be 100 divided by, this is the number of turns, Es by del E. Okay. We can also write here resolution as 100 divided by the number of turns. So with this, the help of this formula, we can find out the resolution of potentiometer. So in this video, we have studied about the control system component, the first control system component, potentiometer, and we studied that potentiometer is an electromechanical transducer which converts mechanical energy into electrical energy. This mechanical energy can be either is a displacement, and this displacement can be either linear or rotational, and the electrical energy or the output of the potentiometer is a voltage. And then we studied the types of the potentiometers, translational potentiometer and rotational potentiometer. Then we derive the ratio of the output and the input voltages for both the types of potentiometers. Then we studied that how the potentiometer can be used as an error detector or the double-ended arrangement. And in the last, we studied the resolution of the potentiometer, how it can be calculated. So I hope this topic is clear to you. Thank you.